All right, and welcome back. In this video, we are going to be going through radical expressions. If you're looking for your guided notes, this does not have a lesson number in it as the other ones do. So the other ones have 6-1 or 5-5. This one does not have a lesson number. So please look for the guide notes that are radical expressions. With that, now that you're here, let's just quickly review what it means to be a square root, because this is all about square roots. So a quick reminder on square roots is that the square root of a number is a number that when multiplied by itself, its product is the number under the radical sign. And that's a pretty informal definition of a square root. But when it comes to an example, if we're talking about the square root of 25, you have what's called the radical sign, which is the drawn shape there. It kind of looks like the long division sign. That means we're taking the square root of 25. Well, the square root of 25 is 5, since 5 times 5 gives you 25. So when we're talking about square roots, we are trying to figure out the number when multiplied by itself gives you the number that is underneath the radical. And if you think of the opposite way, 5 squared is equal to 25. So if we would think about the opposite, 5 squared is 25. So squaring a number, like 5 squared, is the opposite of taking the square root of a number. Just like multiplication and division are opposites, addition and subtraction are opposites, taking the square root of a number is the opposite of squaring a number. With that in mind, let's now go and jump into your guided notes. So a radical expression is an expression that contains a radical sign. For example, the square root of 14x, or we sometimes say radical 14x. It's radical, bruh. The expression under this radical sign is called the radicand. So 14x would be the radicand. A square root expression is in simplest form if it passes these three general qualities. The radicand, so for example, 14x, has no perfect square factors other than 1. So a perfect square is a number when multiplied gives you a whole number. So like 2 squared is 4. So 4 is a perfect square. 3 squared is 9. So 9 is a perfect square. 4 squared is 16. 16 is a perfect square. 25, 36, so on and so forth. The radicand can also have no fractions underneath it. So the radicand cannot have a fraction. So 14x is technically a whole number. It is not getting divided by the square root of 3. And lastly, there are no square roots in the denominator. If there's a square root in the denominator, it is not in simplified form. And we're eventually going to talk about how to get there, but those are the 3 qualities that we look for if a square root expression is in its simplest form. We do have a couple properties here. On the left-hand side of your guide notes, we're going to talk about what's called the product property of square roots. So if we have any numbers, a and b, that are positive whole numbers, if it's a square root of ab, we can break it apart and be the square root of a times the square root of b. If we were to use the example up top with 14x, we could break this up as the square root of 14 times the square root of x. We also have what is called the quotient property of square roots, which is very similar to the product property. If we're taking the square root of a fraction, a over b, we can break that up as the square root of a divided by the square root of b, again, where a and b are whole positive numbers. Let's use this in an actual example, though. Let's say we're going to be simplifying the square root of 50. Well, when we try to simplify it, we want to figure out, hey, are there any perfect squares? We're going to try to write it as a product here. So 25 is a factor of 50, and 25 is a perfect square. So we can rewrite it as a square root of 25 times 2, because 25 times 2 is 50. We can break it apart using the product property of square roots. So now it's the square root of 25 times the square root of 2. And we can simplify. We're going to know that the square root of 25 is 5. So we get 5 root 2, or 5 times the square root of 2. or 5 radical 2. There's a couple different ways to verbalize it. We can say 5 root 2, 5 radical 2, or 5 times the square root of 2. And that came from using the product property of breaking it apart. We also have examples dealing with, what happened? There we go. We can work with the quotient property. We have the square root of 3 divided by 49. Notice that all of it is underneath that radical sign. So we can break it apart to use the square root of 3 divided by the square root of 49. By knowing these perfect roots or these perfect squares, it's going to be able to solve these problems and simplify these expressions a lot quicker. So we now know the square root of 3 is not a perfect square, but we know that square root of 49, that is a perfect square. So it's going to be 7. So we have root 3 divided by 7, or radical 3 over 7, or the square root of 3 divided by 7. There's a couple of different ways to verbalize it. So long as we're saying what's logical, you are all good. When it comes to simplifying radicals and simplifying the square roots, there's another property that we could use, and it comes from finding factors of square roots. So on the left-hand side, I'm going to go through and try to write using the product property. And on the right-hand side, I'm going to be using a different method. I call it the house method, but there's a lot of different names for it, but I just happen to call it the house method, and I'll talk to you why. On the left, if we're trying to simplify 112, we can think about some square roots or perfect squares that multiply with another number to give us 112. For the absence of time here, I'm just going to let you know this becomes the square root of 16 times 7. We can break that up as the square root of 16 times the square root of 7. And 16 is a perfect square. Therefore, we can simplify and we get 4 root 7. So by knowing these perfect squares is going to be really, really helpful for us moving forward. On the right-hand side, I call it the house method. And the reason why is, growing up, when you want to leave the house, someone would always say, oh, are you going out alone or are you going to be with a friend? And in this method, we want to look for groups of friends. So let's simplify 112 as if it's not the square root. We're just trying to simplify 112 and get all of its factors. This is going to go way back to just finding the factors of 112. We can divide 112 by 2, and we get 56. So 2 times 56 is 112. I notice I can't simplify 2 anymore, so what I'm going to do is I am going to circle it. That way I know I can't go back to 2. But I can simplify 56. 56 could be 8 times 7. And again, 7 is a prime number. I cannot simplify that anymore. 8 can be broken down to 4 and 2. Again, 2, I cannot simplify. We can simplify 4 to 2 and 2. Now that I've reached the end of all of my branches, I have to use now the house system. If I want to leave the house, I have to have a buddy. And the house is actually going to be the radical sign. If you want to get out of that radical sign, you have to have a buddy. Well, let's see if we have any partners of the same number. Well, I have 1, 2, and I have a second 2. So that means I can pull out 1, 2. Let's see if I have any other pairings or any other buddies. I have a 2 here, and I have a 2 here, which means that I can again pull out 1, 2. So now on the outside of the radical, I have 2 times 2. Are there any other pairings? Are there any other circles that I need to be aware of? Any numbers at the end of the branches? Yes, there is the 7. The 7 is all alone. It doesn't have a buddy today, which means the 7 cannot leave the house. So it stays underneath the radical. It stays inside the house. And now with this, we can simplify. 2 times 2 is 4, the square root of 7. Notice how we get the exact same answer. So if you don't know your perfect squares, we can use the house method by breaking it apart to finding all the factors and grouping any pairings that we have together. Hopefully that was helpful. Let's go through a couple more examples on that front side. So we want to simplify x squared y, and all of that is underneath the radical. So we can use the product property here. We can break it apart as the square root of x squared times the square root of y. The square root of x squared becomes x because I have two of them. So I'm able to group them together and it gets pulled out. X squared is also x times x. Well, if I have the square root of x times x, I'm looking for the number that gets multiplied together or by itself. Well, I have two x's, so I'm able to pull one out. I found the number that multiplies by itself, and we're left with the square root of y. That doesn't change because there's only one of them. Now on the right-hand side, let's say we're trying to simplify the square root of x to the sixth divided by 16. There's a quick typo on your note sheet. It should be x to the sixth divided by 16, the square root of all that, is equal to the square root of x to the sixth divided by the square root of 16. We can simplify this now to get x to the third over 4. X to the sixth, the square root of that, I'm able to get 3 pairings of x's to pull out. And x times x times x is x to the third, not 3x. It's x to the third. Square root of 16 is then 4. So please make sure you adjust your note sheet accordingly because there was a typo. With that in mind, please work on problems 1 through 6 on the guided notes and resume when you're ready to move on. All right, so the product and quotient properties can be used together to help simplify these radical expressions. If we look on the left-hand side of your guided notes, we want to simplify the square root of 28 divided by 25. Notice how all of that is underneath the radical. That is the radicand, 28 over 25. Well, we can use the quotient property here to break it apart. It's a square root of 28 divided by the square root of 25. We can use a product property or to simplify the square root of 28, and we get 2 root 7, and the square root of 25 is 5. So by breaking apart into the numerator and the denominator, we simplify the square root of 28 to be root 4 times root 7, and that is going to be 2 root 7. Square root of 25 is 5. On the right-hand side, though, we have something a little bit more fun. We want to simplify the square root of 9x cubed divided by 49. And all the variables here represent non-negative numbers, which means that x is always going to be a positive number, which is very, very crucial, and we'll talk about that later. But what we're going to do from here is we're going to use a quotient property, and we're going to break apart the fraction. So we have the square root of 9x cubed divided by the square root of 49. We're going to use the product property to break it apart here. So we get the square root of 9 times x squared times x. And we can do that because x cubed, or x to the third, can be written as x squared times x, divided by the denominator, the square root of 49. Well, the square root of 9 is 3. The square root of x squared is x, and the square root of x just stays the same. The square root of 49 is 7. So hopefully this was helpful. With this in mind, please work on problems 7 through 14 on the guide notes. Please let me know if you have any questions. Keep up the great work, and I'll talk to you soon.